Thank you for joining us in this session. My name is Heitor, and I'm here with Stan. We are both from the AWS Professional Service team, and we are here today to talk about our experience helping the AWS Professional Service organization adopt coding agent and lessons learned that we accumulated so far. So you're going to see that we're going to start with this problem statement to help set the stage and understand the common trap that we have, this blindfolded coding agent problem. Then we're going to go and talk about how can we mitigate and avoid this problem. And to start, have you ever experienced this situation? Like you are assigned to a project, and now that coding agent is available, everyone expecting to deploy things in lightning speed. And now you have the experience saying, can this code agent generate an authentication system for my e-commerce platform? And right after a few minutes, you're going to get an output. First time, it looks OK. Like everything is using the latest and greatest spec or documentation. And when you look deeper, the documentation is there, so it's pretty well structured and so on. But then reality hits the ground. So you're going to dive deeper and see that the agent's not following the session manager that you have in your front-end environment. Basically, ignore all those requirements that you have for single sign-on in your enterprise. And finally, just to keep it simple, like it's volunteer itself to generate more features that you didn't ask. And this is exactly what we mean by fast code isn't necessarily good code. And even good code is eventually not the right code for you. So, because there are many ways to implement things, but you need to implement things following the compliance or the rules that you have in your organization. Just to put this into a different perspective and illustrate this, if you think on your right-hand side, you have the target, like your desired solution, and you are using the code agent to implement that feature for you. If you don't provide enough context about how you're going to build this system and give the guidance how to do that, eventually it's basically using the coding agent blindfolded, and it's trying to guess, navigating through this ambiguity to get to the target. It may or may not deliver what you need. And the session that it's going to be about how can we prevent that. The good news is Kiro has a lot of features, built-in features that can help you minimize the possibility of going off of your target. So one example is spec-driven development that we talk so much. It's basically how can you break down large, complex problem into define the success criteria, the requirements that you have, how you design this solution, break down into tasks. So you can think, if you're planning to drive to a specific location, how you plan your route to get there. Then we have hooks. The analogy that I put here is like using a GPS, because eventually you may get a wrong turn, and the GPS in your car basically is rerouting to help you go back to the ideal course. So you can do this in your environment to define non-negotiable requirements that you have, and if something is going off the plan, you can use this event to go back to the original design. Eventually, you have the steering docs, and this is one feature that you can leverage in Kiro to define what are intrinsic knowledge or design principles that you have in your organization to basically teach Kiro to behave like best-in-class delivery consultant. So in this component, we are trying to define to Kiro, share our lessons learned, how to do trade-off analysis and how to behave when we need to make a decision. And finally, the most common one is MCP. So if you have a tool that you need to access to execute a task, it's available there for you. The main difference between steering docs and MCP is how frequent those things change. So what I would say is steering docs is more design principle. So if you think about well-architected framework that we have that's true over time and persistent, most likely this knowledge should be represented as a steering doc because you use this to understand what good looks like in your environment. And MCP is more for dynamic data. So you don't need to throw all AWS documentation inside the session window and flood the context window of the Kiro to understand what the service feature set is available. You can access those things on demand when needed. But the main question that we have when we are working in ProServe specifically is how can we get to this level of precision? Like I can't afford to have this margin of errors or the coding agent going rogue in different direction. I need to be exactly grounded on the customer requirements. And that's when we start this conversation. So because most of the time we are trying to rush into code phase and asking the coding agent to go fast, even if we don't know what we are trying to build first and what are the possible paths. So if you want to get this level of precision, you need to go way back to the notes that you have about what you are trying to build, translate the context from the human context into a context that I can share with the agent, so agent can be more effective executing the task. So as you're going to see, this is all about how can we find a balance between what we should put in the context window. Because if we put too little, the agent's going to need to navigate through the ambiguity, and probably this is when they can make the wrong call. If we put too much, it's going to flood, and they basically can ignore some important notes that you have about the project. And worse than that, if you have conflicting requirements, like one specific document is saying something and another is saying the opposite, how the code agent is going to decide which one to pursue? So let's do a thing. Like we're going to start seeing how we implement those things inside professional service to give you a sense how to avoid those problems that we are discussing so far. I know this is a 300 session, so I'm going to use just a few minutes to level set everyone. Like, I don't know how many of you have been using Kiro so far, but just to level set and show those components that we discussed before. So I just opened my environment here. And on the left-hand side, I have my project. And right-hand side, I can start a session using Kiro to help me do things. So if you open the Kiro tab, you're going to see that we have all those components that I was discussing before. So spec, the routing plan, hooks, the GPS adjustment. Then we have the steering docs, the design principle, like I mentioned before, and MCP, the tools that are available. Just to give you a sense what those things mean, I'm going to open here and ask Kiro to describe those things for me. So first question that I would ask is, what can you do for me? So what Kiro is available? How can they help us build project? And you can basically chat with the agent right in the session. And it's going to say that I'm here to assist you, code development. I can create a CLI command and so on and so forth. As I mentioned before, we have a few specs. So if you don't want to dive too deep what spec is, I can basically ask Kiro to say, can you explain to me what's inside this spec document? And it's going to try to make sense of what you define in this spec document and define for you what's in there. So let me see if I need to do this spec design agent. And so it's thinking, analyzing what's inside this design document. But as we wait, I can show you actually this in the, okay. So it's explaining to me exactly the problem that I was describing at the beginning. Like how can we translate human context into context that's defined for a coding agent to execute the plan. So everything that I'm describing here is trying to go through raw nodes, distill this information in a way that I can hand over to an agent. So if I go and expand this to see how a spec is structured, we have three main tabs here. Requirements just describing why, what we are trying to build in this spec, like this task list, if you will. In this case, I'm trying to say, I want to be navigate through raw data and create what I'm calling a spec package. That's this context for agents. Then this is how we're going to do that. So I've created those many stages. But if I go to the task list, you're going to see that basically I'm instructing to Kiro. Just 1 second, I'm going to get to the list. I'm instructing to Kiro, say, this is how you're going to navigate through these, execute the task, and so on. And we're going to see this in action in a minute. The other concept that we have here is hooks. So the easiest way to see this, how it works, is actually trying to create one. So I can open Kiro here and ask to create a new hooks. The one that I like that resonate a lot with users that are using this for the first time is update my documentation. So basically what I'm describing here is if I'm trying to build something, and as soon as I save a code base, a new file in my repo, it's going to go to my project README file and update, so the README file is always reflecting what's actually implemented. So if I do this, Kiro behind the scenes is evaluating my prompt here, and I want to create this rule for hooks, defining what's the event that's going to trigger this action, and then what we're going to do since whenever we get this action being triggered. So as you're going to see here, this is documentation sync. The description is every time I'm saving a file with this extension, we're going to prompt the code to say, is there any change or significant change in my repo now that I need to represent in the README file? If yes, make the relevant change in the README file and keep this updated. All right, spec, how we decompose complex problems into task lists. Hooks, how can we keep these following non-negotiable criteria that we have. Steering docs, I think the easiest way is, again, ask Kiro. So I have a lot of knowledge that we put here in the steering doc folder, but one that resonates a lot with users is this collaboration workflow. And just to give an example how this works, I'm going to ask Kiro to describe what's in there. And this is basically telling Kiro how I want the code agent to behave. So at the very top, I'm saying we are working on this together. If you'll see that I'm asking you to do something that's not aligned with best practice, I prefer you to push back and see why this is not a good idea and keep me honest when I should execute things. If we are trying to do a problem solving, I don't want to try to get the quickest solution. I need to go deeper and see the root cause on those things. And another thing in our situation is every time we are building stuff, I don't want the agent to take critical actions. And this is things that I'm describing here. Please don't automatically do git commit, git push, and so on. Ask me if you want to do this, take those actions. And if I ask you to do so, confirm before executing. So this is just an example of things that we describe how I want Kiro to behave. We have many other objects here that we usually load as needed. But this one specifically, if you see at the very top, Kiro has this option to define the inclusion mode that we want. So when we say always, every single session that we load, and one example is the very top, everything that I put as always is going to be loaded for every single session. And if I put manual, let's say, I think this one is manual. So if I open this one, I'm only loading this steering doc when needed. And MCP is the most popular one, so let me see if I can quickly show one example here. I'm going to ask Kiro to describe what's available in this knowledge MCP server. And as you're going to see, it's going to go through the definition of the tools that's inside this MCP and give me a sense what's available there. And by the way, this MCP is available to everyone. So if you want to leverage this in your project, you can include in your development environment. And the idea is I can search updated documentation of AWS. It's gonna list the repos that we usually consume. So it's AWS documentation, blogs, GitHub sample, constructs, and all those things. And I can basically interact with this MCP when I need to get access to your latest data. All right, now that I know spec, hooks, agent steering docs, and MCP, how can I make sense in a real scenario? So I'm gonna close everything. I'm gonna start with this sample project. In this situation here, I'm trying to simulate what usually happens in projects. Imagine a situation that a person went to a reInvent summit or an AWS summit, and they have an idea like, always that I go to those summits, I have these notes that I never consolidate in well enough when I go back to my company, and I need to do this knowledge transfer. I always struggle to remember what I took notes and so on. So what if we have a system that I basically take a screenshot, add notes in my TXT or markdown file and so on, and I share this with an agent, and the agent gonna make sense of this. If I'm asking open questions, not answering my notes, the agent gonna be responsible for searching for the answer and help me consolidate this so I can go back to my company and do a knowledge transfer effectively. The problem is, it's never well-structured like that, a person describing what is needs to be done and how we're gonna execute. It starts with someone having this idea via email, then this move to a Slack thread that people are brainstorming about what we should do. Then someone else replied to the original email saying, what if we use the knowledge MCP that we saw to answer those unanswered questions that we have in our notes? And then they have a meeting, they transcribe this meeting, then they have another session in Slack, the whiteboard solution, and now I have no clue what I'm trying to build. If I just ask Kiro to do that and implement this software for me, most likely it's gonna try to help me somehow. But if I don't structure this context in a way that's gonna be effective for code agent to execute the plan, most likely you don't have what you are expecting. So how can we do about that? Like, how can we improve this process? Remember that I mentioned in the diagram that we have this design agent? Design agent is this spec doc that I created in my Kiro environment here. And the way that I can call it is basically saying, can you execute the task that I defined in design agent? And when I go to a new session and say, I'm gonna start this process, it's gonna understand that I put all those notes about this project in that input folder. It's gonna read all those things and execute the task that I defined in this workflow. So first thing is, I need to read all the input data, so all those files that's in our input folder. Try to understand what are the requirements, non-functional requirements, risk, and anything that we capture from there. And then share this back with the human so they can validate if this is exactly what you're trying to build. So when you go to the build phase, you're most likely going to be successful because you know exactly what are the requirements, successful criteria, and so on. So instead of waiting this to the end to complete, I'm going to skip ahead. I have another one here that I executed. And the output of this processing this input data is in this generated folder. So if I open here and go to functional requirements, for example, I'm consolidating this in a way that I know exactly what I'm trying to build in a consolidated way. So I'm trying to create a content upload interface. I need to have the content storage. I have an AI power summarization feature, and so on. And every single requirements that I'm listing here, I'm trying to put clarity for Kiro, understand what I'm actually trying or how I'm going to assess the completeness of this task. So for this one specifically, I'm saying this is a must-have based on the context, and I'm showing where I got this information from the original email and the meeting notes that I got originally. And this is how I capture the successful criteria of this task. And this is not only for the functional requirements. We have for non-functional requirements as well. So we have, I capture the response time, scalability criteria, how we're going to evaluate the storage requirements. And then, finally, one thing that I would like to highlight here is when I was reading all this context from the raw notes, I'm trying to break it down in two levels. One is business objective, like what are the goals that my leadership or whoever started this project shared at the beginning. So as you can tell, here we have 6 main objectives of this project. So I'm trying to organize conference learning, improve knowledge, answer a question that I don't have, and help me like create LinkedIn posts when I go back to my company and so on. I can make sense of my notes. And this is how I broke down these into requirements. And if I'm trying to think about this from the project management perspective, I also instructed in my workflow to create user stories. So we know how can break down this into small modules or work stream. And in the end of the day, what I'm trying to do here is understand the what, like what we are trying to build. And one thing that I have here, just to consolidate all those notes that we described so far, we have many ways to represent knowledge to a code agent to leverage those things when we are executing a project. During our experience and to understand how you can select which bucket you're going to use, I would use this approach. Like if you're trying to represent a workflow, like I was describing, saying you need to read the files, you need to extract the requirements, you need to understand that you need to map those things. So if it's a very structured workflow, spec may be the answer for that. And important to understand is you need to guarantee that you are tracing the criteria to the requirements. And then when you create a complex workflow, you need to keep this handoff material. So when you go to the next step or next session, the next step in your workflow, they're going to know what to execute next or what you did before. So this is basically the routing planning that you have in your car metaphor. But if I'm trying to do event-driven automation, like when I save something, hooks is important. Highlight here, and based on our experience, try to match these in a time needed. So when you save a file, when you create a file, another important thing is to avoid this loop. If you are trying to edit the same file that generated or triggered the event, try to just list what you should do instead of editing and saving to avoid this infinite loop in your environment. Because this is your GPS routing. So if you're making the wrong turn, it's going to help you go back to the original plan. Then, when should I understand if it's a steering dock or MCP? One thing that I would highlight here is steering docks more for design principles. So if I need to understand what good looks like to make a decision between trade-off, this is when steering docks, it's a good approach. And the steering docks, the most important part is, this is basically when you are trying to drive, what are the minimum amount of information that you keep? So the traffic laws that you need to memorize to understand how to drive in a street. So this is what you put in steering dock. It's important to remember the proper cruising pattern to avoid flooding the context. So if you are saving everything for always be loaded, probably you're going to waste tokens in your environment. And finally, MCPs is for dynamic content. So if you have tools that you need to interact or take action, this is actually the real-time traffic information. So if you need to remember something as needed, like the real traffic information, this is the bucket that you use to represent this knowledge. All right, so this is just to level set that now we understand what we are trying to build, translating the human context to a context that the code agent can behave. But before we go to the execute, there is another important part that's understand among all the possible paths that we have to execute the plan, how can we pick the right one? And for that, I'm going to invite Stan to join the stage, to share this next part of the session. Thank you.
Good afternoon, everyone. I'm Stan, and I will take it from here. So now we have our agent equipped with steering docs, specifications, hooks, and MCPs, but is it enough for our agent to be truly useful in real work? Will this agent be able to write the code which is not only good, but the code which is right? Imagine the situation. You have your advanced agent who is capable to write a sophisticated code and solve complex technical problems. And one day you are asking your agent to provide recommendation for your containerized application authentication mechanism. And your agent just returns you generic OAuth 2.0 authentication instead of referencing you to approved integration patterns for your IDP provider. Or you are asking for recent AWS pricing information, and the agent just apologizes that it doesn't have this information. Doesn't sound familiar? This is an intelligence gap problem that can affect even the most sophisticated AI agents. Development team often reports that their agent can provide technically correct but contextually relevant recommendation due to lack of access to organizational knowledge. And it's not just a minor problem. It's a significant barrier in AI adoption in enterprise environments where context matters as much as capabilities. When developers first deploy their agents in production environment, we quickly realize these limitations. Agent may be excellent in general problem-solving skills, but it lacks a significant context that makes it really useful in real work. Let's take a look into this problem closer. Most of organizations have their valuable information stored in a system which are locked from AI agents. With information such as architecture decision records, internal wiki pages, team standards. Without accessing this information, agents just use general knowledge and cannot build on top of experience of your organization. From another side of this problem, we have external knowledge problem. Knowledge of your agents is limited by training data cutoff time, and it means that they don't have access to information about recent service capabilities, new functions such as functions, and services announced at reInvent. We might not have access to recent pricing information, which is important for cost estimation and evaluation. And we don't have access to security vulnerabilities and patches information that can affect selection of technical stacks and technologies in your system. And in order to solve this problem, we need to find a structured approach which will convert your AI agents from static knowledge repositories into intelligent system which can collect, process, and apply information from both internal knowledge and external current information. How we address this issue in our intelligent AI agent architecture? On the left-hand side of the diagram, you may see components responsible for internal knowledge processing. And on the right-hand side, there is a part of the architecture which processes external data. Let's start from internal knowledge processing. And the first component of our architecture is a layer of data agents. You may think about data agents as specialized agents that has tools that allows them to connect to your internal systems, and we have very detailed prompts, system prompts, which explains how this agent should use these tools to effectively extract information from your internal systems. This agent might be connected to a system which stores reusable artifacts, various code repositories with blueprints and reusable components that you can use in your architectures. Or we can have access to internal wiki pages and documentation, which stores information about services, capabilities, and limitations, and various best practices and industry-approved use cases. When that agent extracted this information from your internal system, we can pass this set of reusable assets into the next layer. On the next layer, we have a panel of expert agents. You may think about these agents as a specialized experts. Each of them is specialized in a certain aspect of architecture. We can have functional fit expert, which determines if a component solves core business problem, or implements all the required features. We can have architecture fit expert, which determines if the component follows the established best practices, such as well-architected framework, and how well it's integrated with your internal applications. We can have security expert who can evaluate if this component follows your security best practices. For example, does it have proper authentication and authorization implemented? And how it stores the data? Does it have encryption at rest? Or we can have operational experts who can determine if this specific component is production ready. Each of the experts of this panel review the components and produce the score from 0 to 100 on how well this component fits the target architecture. A part of the score, each agent also produces summary of where this component fits the target architecture and where the gaps are identified. After all the components are evaluated by expert panels, we can move to the next stage of this process, where we perform ranking and scoring of the assets. We aggregate these scores based on each individual component, and using this aggregated score to form a short list of components we are going to use in our target architecture. Now let's take a look into part of architecture which is responsible for external knowledge aggregation and processing. In order to collect and process external data, we are using implementation of deep research framework. If you will search over internet for deep research framework implementation, most likely you will find white papers from companies such as Anthropic, LangChain, or Miraflow. All these white papers are different in details. However, the core idea of all these work systems is pretty similar. All of them are using multi-agent architectures to implement deep research functionality over 3 major steps. First, they do job planning, then execute subtasks, and finally, they produce aggregated result. Let's take a look into this architecture in more details. So the core component of this architecture is the coordinator or main agent. The role of this agent is to get complex user query and split it into a list of individual tasks. Often coordinator is using special tools, a reasoning tool, which helps coordinator to plan the activities and perform this split of complex tasks into sequence of independent subtasks. And once coordinator split this complex task into set of individual subtasks, it spins up multiple sub-agents and passes these individual subtasks into each of sub-agents. Sub-agents are responsible for processing of the subtasks. And in order to process this information, agents are equipped with a set of tools they are using to execute their subtasks. Once each sub-agent finishes their part of the job, they form intermediate result, and this result headed back to coordinator. Coordinator aggregates results from multiple sub-agents, performs cleaning, aggregations, and produces the final result. Let's briefly talk about tools we are using in our architecture. First of all, we are dealing with external data, so we need an instrument to search data over internet. So we have internet search tool. Once we identified sources of information and we know where exactly this information is located, we need to provide functionality for our agents to read this information. So we need some type of browser. You may use one of open source implementation of browsers such as Chromium, Headless, or Playwright, or you may choose one of specialized components such as Agent Core browser. Our agents also have access to file system and read and writing operation, and usually we use this operation for intermediate results processing and state management. Often, deep research requires accessing specialized sources of data, such as code repository on GitHub, and if this is the case, you may put MCP server and, for example, Strands agent provide the functionality to wrap any MCP server into a tool which you can use in your agents. What are the lessons learned when we build this deep research implementation? First of all, deep research framework is quite complex system with a lot of moving parts and components, and observability is a key component for successful implementation of deep research functionality. Using proper observability, you can quickly answer the questions, what exactly each sub-agent is doing, what tools are available for sub-agents, how we use these tools, and which results every sub-agent produces. Another lesson learned for us was we need to understand which exact tools are available for each sub-agents and how sub-agents are using these tools. We found that sometimes agents are using tools in a completely different way from what we expected. So it's important to make sure that agents are using the tools the way you're expecting. And the final lessons learned was that optimization of deep research framework is about finding proper balance between resources you are going to spend for your deep research analysis and quality of the output. It means that you can technically spend hours and millions of tokens without significant improvement of quality of output results. So it's really important to have in place configuration which you can quickly define depth and breadth of deep research functionality. And you can flexibly configure this balance to find proper balance between resources you are going to spend and quality of outgoing result. Okay, with that, we will switch to the demo. Okay, I will start at the same stage where Aitor showed before. So we have our demo project, and we passed first two stages of this project. Just to remind you, in stage one, we analyzed input documents, and we extracted information, what is the scope of the project, and if this project is POC or it's fully functional application. So all these details that we can derive from source information, from project documentation. And on stage two, we generated functional and non-functional requirements, as well as traceability matrix and user stories. So now we can continue to the next stage. So I will type continue. Our agent maintains the state of the process, so it knows exactly where we are right now, and it will continue with the first task of the next stage 3. The next stage in our process is generation of system architecture documents, and at the beginning of this process, our agent checks if we have access to our backend. Our backend that we discussed before is available to our agent through MCP server. So this one, Intelligence Hub server, provides access for our Kiro agent to our backend, which takes care about this internal and external information. When this MCP server is available, agent submits functional and non-functional requirements to our backend, and backend produces the outgoing results. So it will take some time, so I will switch forward to show how it looks like. So when agent submitted the information to our backend, it receives a job ID that agent can use to, first of all, check the status of the job, and the second, it can use this job ID to get the results of the processing. You can see that agent is instructed to check status periodically, time to time, and it keeps iterating until it sees that the status of job is changed to completed. It means that backend finished the processing of the job, and our agent can receive the results using a separate getResults call. Let's fast forward and see what did we get from our backend. So our backend, Intelligence Hub, produces the result, which consists of two main parts. As we discussed before, we have two different workflows for internal and internal data. So our outgoing documents are structured the same way. We have the first part of the document, which lists all the components our experts evaluated and produced a short list. We can see that top asset identifier is Agent Core Runtime Blueprint, which is our internal blueprint, which guides agent on how to build and deploy agents on Agent Core. Our sample project is involving development of agent, and that's why this blueprint is determined as a strong fit for this application. If I scroll down, I can see, sorry, where is it? We can see the whole short list of the components, and for each component, we can see a breakdown of expert evaluations, as well as summaries of all the experts where certain components fits the target architecture. And at the end of this document, we have a block of data associated with deep research analysis. So once deep research analysis is completed, it adds the results into the same document. So now our agent have following documents, and it has access to functional requirements documents, to non-functional requirement documents, and the results of our Intelligence Hub evaluation. And on the next stage, agent will generate system architecture. I forwarded to the end of stage 3, so now I have system architecture generated. So we can see it's quite a detailed document which describes all the layer of architecture with recommended services. In our sample project, we asked to generate serverless applications, so most of the services are represented by serverless AWS components. When we have our architecture generated, our next step is to check what is the quality of architecture generated. We have quality assurance step. Where our agent instructed to perform quality analysis of a package of the documents to determine if we can consider this package as a finalized, or we need to do one more iteration over this package. So our agent evaluates the package across 5 weighted categories, like requirements, architecture, security, implementation, and so on, and finally produces a final score. If the score of the package is below the bar that we predefined, it means that the agent will need to do one more iteration of requirements refinement and regenerate the requirements. If the package exceeds the bar in terms of quality, we can consider that architecture is successfully generated and we can move to the next stage. Next and final stage of our process is security assessment. You may ask why we are doing security assessment after architecture generation. This security assessment produces a package of the documents for our delivery security review, which is a step in project delivery when AWS Professional Services provides this set of documents for security assessment by our application security specialists. And our agent generates this package of the documents that is significantly simplifies work for our consultants. So you can see that we have generated threat analysis document, which identifies risks associated with certain components we identified for implementation. We have security controls as a set of controls we need to implement in order to make sure that application is secured, and the set of tests that are required to implement to make sure that security controls are properly configured and applied. That's pretty much it for this agent. Today we are demonstrating first agent from a group of agents we are building for professional services. This one is a design agent that processes project requirements and generates a specification package. The next stage in this process could be, first of all, this package can be handed over to delivery team to implement the functionality, or this package can be source of the data for the next agent, the build agent, which can use this information to automatically build the solution. If you're interested to see this build agent in action, please join us at AWS Professional Services kiosk, where we have demonstrations for this agent and other agents. And with that, I will hand it over back to Aitor.
Few final comments is, as you're going to see, like those coding agents is helping us build things at lightning speed, and it's changing the dynamics. It's not a driving exercise anymore. It's a launch experience. Because if you don't plan this properly, most likely you're going to go very fast to the wrong direction. And that's why now it's more important than ever that you plan your project properly. So when you launch with vision, like the agent gonna land where you need, like with precision. With that, we're gonna open for questions. Please fill out the form at the end. And if you need to dive deeper on the topics that we discussed here, this is the QR code that you have some learning there. But we have some around 10 minutes for questions.